Hello, everyone. So today, the system design data estimates series, I have one more very interesting uh, system design problem, which is called search engine. This is again something which is very common interview system design question, which is asked by many companies. I see people here, they most of the time, have some struggles when it comes to data estimates for search engine. So I'll be covering here some of the high level with some real numbers, which are going to be, which you're gonna see in real, how should be the uh, clarifying requirement that should be that we should place upfront to the interviewer, and then gradually moving towards a good solution. Always remember, whenever we talk about any system design, data estimations, this is a very important topic. But most of the time, we all just jump into making those blocks and diagrams, which I think is a standard, a very pretty common way. It is very easy for anyone to learn to make those rectangles using Miro or Draw.io and then use arrows to connect all those components at the same time. But I see people struggling and having difficulties in order to understand the foundation, the fundamentals behind those blocks, what we will be doing. For example, data estimates, throughput, latency, the communications between all those components. These are the important things. You must know whatever service you're going to create, whatever component you're going to create, how much data that service will consume, how that service will behave when it runs on a production. Do we need any scalability? What number would you like to give for the scalability based on the load? All these numbers, they are very very important. So I'll be covering with my system design series all these basic fundamentals. When you get the confidence of all these, like data estimates, throughput numbers, latency numbers, data storage numbers, bandwidth numbers, and then you can correlate all that and come to a real system design solution with all scalability, fault tolerance, resilience, and all that. So let's not wasting time jumping into this search engine storing index web pages. There are many search engines right now in the market. Google is one of the most popular search engine. So, when you say search engine, you also must understand what is this search engine, right? So, before I explain, you go to the question which interviewer asked. Uh, I must ask you, like, what is search engine, right? What is search engine? Search engine uh, is how search engine is working, how it is working, like what is behind those search engine. Uh, so I'll try to cover a bits, some bits and pieces of that. Would not go more detailed into detailed understanding of search engine, so that you are aware of um, uh, some basic concepts. In my some other future videos, I'm planning to have separate sessions, separate series on where I will cover all these topics in detail, like the architecture, the architecture behind those search engine and all that. So yeah, so let me quickly give you. Search engine is what it is: a software system which is designed to carry out web searches. What does it mean? Enabling users to find information on the internet. So whenever you write something into Google, the search engine provides a list of web pages, images, videos, or whatever contents you see in the result, right? So what happens behind the scene? So there is a concept called crawling, there is a concept called indexing, right? There is a concept called ranking. On a very high level, these are three most important concepts which is always there whenever you talk about any search engine: crawling, indexing, ranking. Let me quickly summarize all these. Crawling is search engine deploy automated programs, they are called crawlers or spiders, to traverse the web. These crawlers, they follow links from one page to other, discovering new and updated content, right? Indexing, on the other hand, is once a page is discovered in step one, that is by crawlers. So crawlers and spiders, they are crawling everywhere in the web, following the links from one page to other page. Once they discovered something, right? Once a page is discovered, The search engine analyzes its content, including text, images, metadata, right? And that is where, which is very important, the concept which we'll be covering, indexing and ranking both, is called search engine optimization techniques. I will cover that also in some other video. But yeah, let's focus on indexing. So when you get a page which is discovered, your search engine analyze its content, including text, images, and metadata. This information is then stored in vast database called index, which serves as the repository for all content that the search engine has cataloged. Okay. Then ranking comes in. When a user submits a query, you write something into Google, the search engine algorithm, it access what? Access the indexed pages, whichever you indexed in step 2. So first is crawling. Crawlers go follow the links and then they try to find out a page. Then second, indexing. They once they get the page, they try to analyze its content, metadata, images, and when they found it is meaningful, they stored in the index page, right? Index database, which is a single source of, I would say, repository for all web content. And then comes ranking, step 3. When a user submits a query, search engine algorithm assess the index pages, okay, to determine their relevance to the search item. Factors such as keyword preferences, page quality, user engagement, they all are considered. The most relevant information or the result presented to the user in a ranking order. So it's not something wherein Google or any Yahoo, any search engine. So whenever you write something into the Google, there is no real time, all these things happening. No. These crawlers, they are working in an automated fashion. You can say they are working automatically. Even before you search something, there has been many crawlers who are crawling every single, based on whenever their automated programs are running, they're crawling the entire web and they're making an index repository. Okay. So ranking is also happening on the top of it. So whenever you submit any query, then the algorithm, it go to index repository, find out the pages, and based on whatever preferences you pass, it gives and present you the the result. So indexing is critical component of the search process. During indexing, the search engine evaluates content of each page, noting elements like keywords, freshness, user engagement matrices. For example, how many times a page is visited. So that is called user engagement. The more the page is visited, the user engagement matrix will increase. The rank for that will increase, right? Freshness of the page. Keywords. Let's say there is a page which is very old. No one has seen it. So I think the rank for that page will be much lesser, right? And some of the key elements. This evaluation helps the search engine understand the page subject matter and relevance to the potential queries. Proper indexing ensures that when a user searches for information, the search engine can quickly retrieve and display the most matching pages from its index. Okay, so now again in summary, search engine functions through a continuous process of crawling, which are working in an automated way on the web, and then indexing the content for quick retrieval and ranking it based on the relevance to the user queries. So this is called search engine. Over here, coming back to the question, we are talking about data estimates for storing indexed web pages. Coming to the question, estimate the storage required for indexing 1 billion web pages. All right, 1 billion web pages. Each page requires 10 kilobytes for metadata and text, plus 50 kilobyte for image thumbnails. Now, this is the question. I think question is pretty straightforward. We have a requirement to find out the storage estimates for 1 billion web pages. Isn't it? It's too huge number. Each page requires 10 kilobytes, and that not is only 1 billion. Every single page, it requires 10 kilobyte for metadata and text, plus 50 kilobytes for image thumbnails. Okay, so let's talk about clarifying requirements. So over here you see total pages. So total pages is 1 billion, right? Which is 9 zeros. Metadata plus text is 10 kilobytes per page. The image thumbnails is 50 kilobytes per page. Now, storage per page, because this is the unit thing that we need to find out. So we have storage per page is like 10 KB plus 50 KB is equal to 60 KB. right? So this is storage per page. Now the target is not for one page, it's for 1 billion pages. All right, 1 billion pages. So 1 billion is 9 times 0 into 60. So when you do 9 times 0 times 60 kilobytes, so it will come around like this. Now, you can do this division, but instead of this, I will always try to go on these zeros because I like these triplets. So these three triplets KB is MB. So till here we got MB, three triplets MB, here is GB, and then we till here we got 60,000 GB, and then three triplets GB is TB. So 60 TB is the answer, right? So total storage is 60 terabytes. Always remember, memorize these triplets. They play a very important role in coming to a number which is very, I would say, very key factor. It's an important key factor in determining the total space storage in terms of terabytes. I think you must learn at least petabytes, which is very important, uh, and some of the basic concepts. So yeah, so that was something which was in form of numbers, calculating the total size, total storage requirement for 1 billion pages. So it is 60 terabyte is the data. Like, so now you can imagine the index part where we are kind of preparing an index repository. We would need 60 terabyte, right? Which will store metadata and text, and then images also, images, thumbnails. So now we can also understand the fact when we talk about search pages, search engines, whatever it is, right? We are talking about much more on that because we have to store rankings, we have to store user preferences, we have to store the freshness of the page, and many more things which are there. We all have to store. So this is a roughly approximate number. You can talk to an interviewer that, okay, this is for total pages requirement. Now what comes next? Do you want me to store these details for every, like, for let's say 1 billion pages? You should know what is this ranking and all that. So I would definitely say, if he not saying he is fine with this metadata plus text, so storing everything here, I think it should be okay. Okay, so the system will need approximately 6 TB uncompressed and 30 TB compressed for indexing 1 billion pages. So thank you very much.